All right, gas law notes. Please have out your paper that says gas law notes and then turn to the section that starts Boyle's law. You will see it starting with question number 5. Boyle's law is one of the gas laws that we're going to study in this unit. We are going to see that the variables we'll be studying throughout this unit are temperature, pressure, and volume of gases. And here you see that temperature is not represented. It is assumed to be held constant. So we're going to see what effects just changing pressure have on volume and changing volume have on pressure. So this is the formula that you'll need to be aware of and use. Let's get started. Before we get too far into this, I just wanted to quickly remind you of what kind of units you have for pressure and volume. So if you're looking at a numeric value in a calculation, in a word problem, and it has one of these units right here, then it is a unit of pressure. So a number with mmHg after it represents a pressure, a number with atm after it represents a pressure, a number with kPa after it represents a pressure, and a number with torr after it represents a pressure. Of course, there's a couple other units of pressure, psi, pounds per square inch. You won't see that used here in these notes, and pascals, instead of kilopascals, pascals. Again, I won't use pascals. I will focus and use only these for the most part. You also have these 4 units of volume that could be a possibility. Of course, there are other units of volume, but these are the main ones you'll see. So if a number has ml after it, it represents milliliters or volume. If it has L, it's liters, cm is centimeters cubed, and dm is decimeter cubed. All 4 of these represent volume, and these 4 over here represent units of pressure. So now you should be looking at question 5 in your notes packet. Again, you are on question 5 in the gas law notes portion of your packet, and it is going to start with question 5. So you may need to flip the page past 1 through 4, of course, to get to question 5. So here it says a gas. Here's the word problem. I'm not going to spend the time in these videos to read it to you. Instead, I'll ask you to pause the video and read it, and then we're going to label things as we come across numbers and formulas. Let me correct myself here. I meant to say numbers and units, numbers and units. Okay, so hopefully you pause the video. As you see here, this is question 5. As I come across this first number, I'm going to label with a V. I know it's volume because of milliliters. My next number is P for pressure because of kilopascals. We're looking for a volume, so we're always looking for that question mark, how many or what will, those kinds of words will indicate that's what we're solving for. So we have this volume at a pressure of this. And I know that this is pressure because it has atm. So I knew this was volume because of milliliters. I knew this was pressure because of kPa. I read that I'm solving for volume, and I come across another number with a unit, and I know that this is atm as a unit of pressure, so I labeled it as a P. Now, we need to be able to establish what our 1s and our 2s are. Remember that our 1s and our 2s, our 1s are together and our 2s are together in terms of the word problem, meaning the same instant in time will be recorded as a subscript 1 or 2. It technically doesn't matter mathematically whether you make them 1s or 2s, but it makes more sense to make the thing that seems to happen first be 1s and the later conditions be 2s. So these are together, so they have to be the same thing, meaning these happen at the same instant in time, so they both should have the same subscript. I went ahead and made them 1s, and then this is a volume later, and this is the pressure later after time has passed. So the labeling is extremely helpful and important. Please consider doing that as you work through these problems. So then we have our generic formula, P1V1 equals P2V2. We're going to plug numbers in from up above. I plug my pressure in where pressure goes. And remember, these are side by side, equal side by side. So we're multiplying on this side, multiplying on that side. So we're going to take our pressure volume of 312.78 kPa times 643.89 milliliters. Got that from the word problem up here. And then I'm going to set that equal to the other pressure, 5.376 atm times V2. So V2 is what we're looking for. Here is our formula. And now we're going to talk about the math. Before we can actually perform this calculation, once you've put the generic formula, I call this the generic formula. That is a must for points on every calculation you do, not at the top of the page. Every single calculation should have a generic formula. Then numbers with units underneath, and then we're going to solve. But everything should have a generic formula, numbers with units, and then we're going to solve. Before we can solve this, we want to pause and say, what do I have 2 of? In this example, I have 2 pressures. the two pressures, or if you had two volumes, or if you had two temperatures, must be in the same unit. So if they're not in the same unit, get them to be the same unit. So in this problem, I could get this to be the ATM, or I could ATM to be KPA. I have chosen to make both of my units KPA. In your practice problems, I will indicate where I want you to go, what kind of units of pressure or volume I want you to use. And if I don't, then you get to choose which direction you go. Okay, so we're going to convert and get both of our pressures into KPA. We got to do a grid to do that. We know we're going to take 5.376 ATM, and this is my conversion factor. We practiced this in class prior to today, these sets of notes. So we know 1 ATM equals 101.325 KPA. So an ATM would cancel, leaving me just KPA units, multiply across the top, divide by units on the bottom, and there we have our KPA. So now we're going to substitute that in here where we see ATM. And we're going to change the ATM to KPA. Now I can perform my math skills because I'm going to reevaluate and say, okay, I had two pressures and they're both in the same unit, so now I can proceed with my math. So we're going to multiply these two numbers because there's no unknown with them. Multiply those two numbers and then divide by this number, right? Because we're multiplying times are unknown, so to get rid of the KPA number and to have V by itself, I must, because it's multiplied, I must divide both sides by 544.72. So we're multiplying on the left, dividing by the number on the right. When I divide by this number on the right, my KPA units would cancel, and I'd have milliliters left, and that would be my final unit. And then when I do that, I get 369.72 milliliters. I'm rounding most of the time to 2 places past the decimal. Please take a moment to pause your video and make sure that you understand this, re-listen to it if you need to, and make sure you can physically get this answer on your calculator. Again, to receive credit, you must show everything you see on the screen with the exception of the labeling, although I encourage labeling. You must show a generic formula, numbers with units, an answer with units, and any grids that you must do in terms of converting units. Okay, now we're going to go on to example number 6. In example number 6, go ahead and read that to yourself and try to label things. So pause the video and try to label things as either P, V's, or T's. We labeled this as volume because of milliliters. Saw this next number, and it is a pressure because of KPA. We're trying to get to this new volume at standard pressure. So new volume is what we're solving for at this pressure. If you ever see or read the word standard pressure or standard temperature, that actually gives you a number without giving you a number. Let me explain what I mean. So these are all our standard pressures. These are all our standard pressures. So any of these can be used as a numeric value for the word standard pressure. Of course, we don't want to have to do a grid, so we might as well pick whichever standard pressure matches up with the unit that we already have of pressure in our problem. So in this problem, we already have KPA. Therefore, I should pick my standard pressure to be KPA. In this case, 101.325 KPA. So remember, standard pressure means pick one of these standards, these are the conversion factors and the standards, that matches up with the same unit of pressure you already have in the problem. Okay, so then we're going to come up with our generic formula. There's our generic formula. We're going to plug in what we have. We have 954.31 kPa. That's what P1 is. Remember, I made these both 1 because they're happening at the same instant in time. These are 2s because they're happening later. So I'm going to multiply P1 times V1 equals P2, which is 101.325 kPa times V2. So I'm going to pause and say, okay, what do I have 2 of? I have 2 pressure units, so I must then check to see if they're in the same unit, and they are. So now I can go ahead and proceed with my math. Just like last problem, in this same kind of situation, because we're solving for the same variable, we're going to multiply these 2 numbers on the left and divide by this number on the right. So we're going to take 954.31 times 45.78, and then we're going to hit equals, and then we're going to divide by 101.325. When we do that, the units of kPa will cancel, leaving us only units of milliliters. So we know we're done because we have the correct unit, and we just have to do it correctly on our calculators. So take a moment to see if you can get 431.17, and the unit would be milliliters. Okay, so what I wanted to just remind you about here is that you need to have a generic formula, numbers with units plugged in, and an answer with units. So this is the modeling I expect you to use and the way I expect you to set up the problems in your own practice. All right, let's go on to question 7. In question 7, we have labeling to do here, just like we've been doing. So take a moment, pause the video, and label your pieces, and let's see what we have. You should have had this as a volume because of milliliters. Standard pressure, again, remember standard pressure means I'm giving you a value without actually physically giving you a numeric number in the problem. Then I'm going to say, what would the pressure be? So we're solving for pressure this time at this volume. Okay, so my standard pressures are as follows. And this time, I'm going to pick a standard pressure that matches the other pressure. Well, it doesn't have another pressure, right? But I specify that I want you to solve in torr. So I want you to solve for torr. So we're going to pick our standard pressure to be our torr value. So 760 torr, because that's the standard pressure in unit of torr. So we're going to give our generic formula, plug our numbers in, 760 torr for P1 times V1, 8605 milliliters. Remember, I made these both ones because they happen at the same instant in time, equals my P2, which is what we're solving for, times V2. And now we're going to do the math. So we're going to pause here before we do any calculations and ask ourselves, what do I have 2 of? I have 2 volumes. So I check to see, are they in the same unit? And they are, so I have no converting to do. Now I just need to do the math. So I'm going to multiply the 2 numbers on the left and divide by the number on the right. When I divide by 33.50 milliliters, I'll divide it by both sides. When I do that, my units of milliliter cancel, leaving me only units of torr, which is what we would expect if we were solving for a pressure. Pause your video and do the math on your calculator, and then restart and check your answer. Okay, you should have gotten 1952.18 torr. Okay, example number 8, which I believe is the last example in Boyle's Law calculations. Please take a moment to pause this video and label your numbers so that you are in good practice of labeling P's, V's, and T's. Okay, so this is a volume because it has milliliters. This is a pressure. I made them both ones because they're happening at the same instant in time. 0.9609 liters is a volume. And if this number isn't your number, in some years I had this as milliliters, but I want this to be 0.9609 liters, so correct that. If yours does not say that, it should, but if it does not, please correct it. And we're going to proceed now and just... All right, I paused the video myself on my end to double check. My worksheet shows this as it is, 0.9609 liters. So if it does not show that, correct it to that, and let's proceed. This is a volume unit, so I labeled it V2 because these were occurring at the same moment. And so I made them my ones. And we are solving for, didn't even highlight it here. Oh, I did. We're solving for P2. All right, so what's the pressure? So now we're going to set up our problem here, giving the generic formula P1 V1 equals P2 V2. 31.59 torr is P1. 26.68 milliliters is V1. We are solving for P2, and we have a volume of 0.9609 liters. Before I do anything on my calculator, I'm going to pause and say, what do I have 2 of? I have 2 volumes, one's in milliliters, one's in liters, so I need to give them both to the same unit. Doesn't matter which way I go technically, but read the entire question because I may ask you to go a certain way. So we're going to need to do a grid. We're going to put them both into milliliters in this example. So I took my liters and converted it to milliliters by saying 0.9609 liters. We know 1 liter equals 1,000 milliliters, so we know our 0.9609 liters is actually 960.9 milliliters. So we're going to substitute that in, and then we're going to do our math. Now that we have like units for the 2 things that we have the same 2 of, we have 2 volumes. So because we have 2 volumes, we had to work towards getting them in the same unit. That's what we did with the grid. We're going to then multiply the numbers on the left and divide by the number on the right. When I divide by 960.9 milliliters, milliliter units cancel, leaving me only units of torr. Pause your video and see if you can get what your answer is, and then check it, unpause and check your answer. Okay, let's see. We should have gotten 0.8771 torr.